All right, so if you plug in 3 here, you're going to get a 0 on the bottom. And so we would say, like, you could plug in 2.99 to see what's happening and 3.01 into the calculator that's seeing what's happened. So when you plug them in both times, you're getting a really large positive number. So both times we say it's going to positive infinity. So you just describe that and say, as it's coming from the left side, it's going to infinity. From the right side, it's coming to infinity. Um, so you could say that it does not exist because it's getting really large, but saying it equals infinity actually is telling us much more precisely why it does not exist. So we would say the limit equals infinity. On this one right here, if we want to describe the behavior, if I plug in 2.999, so I'm saying the limit as 3 approaches from the left of x, and then I want to do it as it approaches from the right of f of x. When you plug in 2.9999, it's going to give you a negative number on the bottom, so it's going to be negative infinity. When I plug in 3.0001, you should see it's a positive large number, so it's going to positive infinity. So on the back, you can say that there's a vertical asymptote if your function is going to infinity or negative infinity on either side of the value. So this right here, we would say the limit as x approaches 2. So we know that's a vertical asymptote just by knowing because it makes bottom equal 0. But if we say the function as it equals 2, then this is going to positive infinity each time, so it's going to infinity. Now this one, though, if I do the limit as x approaches 1 from the right, so that means I'm plugging in 1.001, then that should be getting positive large, so that's going to be infinity. But if I do 1 from the left, that's when I'm going to negative infinity. So the limit doesn't actually exist if you do the limit of the whole function. So if you said the limit as x approaches 1 of f of x, now that does not exist. So on this one here, I'm going to go ahead and factor out my x. So I'm going to have a minus 2 and a plus 1. So there is a hole created right there. So this one would be a hole, and this one would be an asymptote. So if you want to do the limit as x approaches 2 from the left of my function, and then limit as x approaches 2 from the right of my function. So that's plugging in 1.999. So it's positive over negative. This would be plugging in 2.001. So that's positive or positive. So we're going to positive infinity. And this one right here could actually, if you want to do the limit, you could actually get the number that it was going to. Thank you.
Appreciate it.
So if we're going to do this function here as x goes to infinity, you'd say if I put a really large number in the top and bottom, so like 6 times a million squared over 2 times a million squared plus 1. And then you divide those numbers, we're just going to get 6 over 2, which is 3. And so this is like the horizontal asymptotes that you guys had learned before. And these are some rules right here that you can follow. Hold on a second. Shh. I'm almost done. So if you plug it in here, you look at the polynomial. So it's 4x cubed and negative x cubed. So you would divide those and we'd get a negative 4. Now in questions like this, it's saying that I have an x squared and it says 10 to the 10th times x. So it's not 10 to the power. So an x squared is still larger. So that's going to be growing faster eventually. So this is going to be going to infinity, or does not exist. We could just say does not exist. So this right here, when I square root, and that actually gives you absolute value of 2x. A lot of you guys think it's just 2x, but it's not. It's a plus and a minus when you square root. Right here. So when I plug in positive infinity, I'm going to get the same answer out, so I get 1. But if it had said negative infinity, you would have gotten out negative 1. Oh, look, it's right here. So negative infinity, you get negative 1. So if I plug in infinity in here, I'm going to have x to the 5th over e to infinity. So right here it tells you exponential function. So an exponential function grows faster than any power function. So it's telling me the bottom's growing faster. So if the bottom's growing faster, we're getting a limit of 0. And then it says that any positive power grows faster than a log. So here's a positive power, and then it's growing log. So this is like going to be x to a 0, really, though, because 1 over a million would be x to a 0 over ln of infinity. So that's 1 over ln of infinity. That's going to be going to. So that should be getting larger and larger each time. So it's not going to be approaching any number really. It's just going to get bigger and bigger and bigger. So cosine pi over a really large number. So cosine, that'd be like cosine of pi over like a million would be getting really close to 0. So really you're asking yourself, what's cosine of 0? Cosine of 0 is 1. Let's see, this one, your bottom has a higher exponent, so you get 0. This one, you'd be getting the same. Let's see, that would be 9x squared on bottom. Same, you divide, so we get 3 9s, which is a 1/3. All right, on the back, I already graphed these for us. And they're the functions from the front, but I want you to be able to visually see. So when you look at this is a horizontal asymptote at the 3. And that's what we get when we divide 6 over 2. This one right here, your graph, you should be getting a horizontal asymptote. This number right here is 1/9, and that's what it's approaching. And this one right here, see from the right side, it's approaching 1, and from the left side, it's approaching -1. And then sine of x over 1, we have proved that as you go to 0, it's going to 1, and then it's going to 0 in all the other directions.